So by now, most people would have seen quite a few reviews about FSD in Australia and both influencers and journalists testing it out. I was surprised to see that quite a few of them didn't really understand the mechanisms going on in the background, didn't understand the history of how Tesla got to where it is now. So I thought I would get Google to make a video with Notebook LM just to kind of explain the different approaches and how it worked. And hopefully before too long, Tesla releases FSD as a subscription and we can make some videos for you.
In the race to build a self-driving car, there's this massive split, a $1 trillion disagreement that's not just about technology, but about, well, philosophy. Today, we're going to dive into the two really different ideas that are battling it out for the future of our roads. Alright, so here's our game plan. We'll kick things off with the two core philosophies. Then we'll compare the mapped world of a company like Waymo to the learned world of Tesla. After that, we get to see how this all played out in a pretty wild real-world test before we ask that big $1 trillion question. So you've got to understand, this isn't just about Tesla versus Waymo or one company against another. No, this is a clash of ideas. It's a fundamental fight to define how a machine should see and navigate our incredibly complex world. I mean, it really all boils down to this one question. How do you teach a car to see? The answer you choose dictates absolutely everything. The hardware you use, the software you write, the cost, and maybe most importantly, how fast you can scale this technology to the rest of the world. The entire industry is split on this. Okay, so you've basically got two camps. On one side, you have the superhuman senses approach. The idea here is to use things like LiDAR and radar to build a perfect digital twin of the world before the car even moves. Then on the other side, you have the human-like vision approach. This is all about teaching the car to see and react in real time using only cameras, kind of like we do. Alright, let's dive into the mapped approach first. This is championed by Waymo and, frankly, most of the robotaxi companies out there. Their whole philosophy is about careful preparation, having backups for your backups, and maintaining absolute control. Waymo's strategy really rests on three big pillars. First, a whole suite of sensors giving it this 360-degree multi-layered view of the world. Second, its AI is modular, so different parts handle seeing, predicting, and driving. And third, and this is a big one, it heavily relies on pre-mapped areas. This means the car only drives where it already has a perfect digital blueprint of every single street. Now, at the heart of this strategy is LiDAR. It's the bedrock of Waymo's entire safety case. It works by shooting out laser pulses to build this incredibly precise 3D map of everything around it in real time. It basically gives the car a kind of superpower, a perception that we just don't have. And this is the perfect example of their point. Waymo argues that in these weird edge case situations, like a sudden dust storm in Phoenix, a camera can get blinded, but LiDAR, it can see right through it. For them, this kind of redundancy isn't a nice to have, it's an absolute must for safety. Okay, now let's flip the script completely. Let's talk about the learning approach. Tesla is the big outlier here. They're making this huge contrarian bet that you can solve the entire self-driving problem using just vision and a truly massive amount of data. This quote from Elon Musk really gets to the core of their philosophy. The argument's pretty simple. Humans drive with eyes and a brain. The world is literally built for us to navigate this way. So if you want a car that can drive anywhere, the most direct path is to replicate that system with cameras and a powerful AI. It's a first principles approach. And here is where you can really see the difference that philosophy makes. I mean, look at the hardware. A Waymo car has a sensor setup that costs over $12,000. A Tesla's just a few $100. This isn't just about saving money, it's about scalability. It is infinitely easier to put 8 cameras on millions of cars than it is to install a complex LiDAR system. So if you're not using all those expensive sensors, what's your secret weapon? Data. An absolutely astronomical amount of data. Tesla's fleet is expected to gather 50 billion miles of driving data every single year. A lot of these cars are running in shadow mode, just silently watching how humans drive, creating this feedback loop that no one else can even come close to matching. But, and this is a really crucial point, it's not just about having a ton of data. Most driving is boring. It's the same thing over and over. The real challenge and the whole point of collecting all this data is to find those super rare 1 in a million moments, the weird intersections, the kangaroo jumping out. That's the stuff that's actually useful for training the AI to handle the unexpected. This data is what fuels their end-to-end AI. So instead of a bunch of different modules, it's one single neural network. Video from the cameras goes in one end, and driving controls, steering, accelerating, braking come out the other. To do this, they actually ripped out over 300,000 lines of human-written code. And that's the key. They stopped trying to tell the car how to drive with rules and started showing it how to drive using millions of real-world video clips. So all of this brings us to the ultimate test of this whole learning idea. Can an AI trained almost entirely on North American roads, where we drive on the right, suddenly figure out how to drive on the other side of the road in places like Australia and New Zealand, all from a simple software update? And at first, the results were just astonishing. People who got the update described it as surreal. The car was just driving. It was confidently handling roads with no line markings, even in thick fog, like it had been doing it its whole life. This is the promise of a general AI solution right here in action. But then reality hits. This is still beta software, right? A reviewer went off one of the known routes, and the system made a huge mistake. It tried to turn right from a left turn only lane straight into traffic. And that's the core risk here. The AI can get most things right, but when it fails, those failures can be really, really bad. And yet, the moments of magic just kept happening. For someone using it for the first time, seeing the car handle a complicated roundabout all by itself was just mind-blowing. I mean, these are situations that even human drivers get confused by, and the AI was just navigating them smoothly. It shows the system is actually learning complex behaviors, not just following some pre-written script. And then, another stark reminder of the gap that's still there. The same reviewer's car cut off a motorcycle while merging. It was a clear error that a safe, defensive human driver just wouldn't have made. It really highlights that the AI is still missing some of that nuanced, cautious judgment that's so critical for sharing the road safely with everyone else. So that real-world test, with its incredible highs and its scary lows, perfectly sums up the state of this whole race. You've got two fundamentally different bets on the table, with trillions of dollars and, our safety on the line. This table lays out the trade-off perfectly. Waymo is playing a slow, expensive, super controlled game. They're prioritizing proven safety, but only in these limited, mapped-out areas. Tesla, on the other hand, is playing a fast, cheap, and scalable game, betting they can solve the safety problem while deploying everywhere at once. You just can't have it both ways. Now, to really understand Tesla's long-term bet, you have to get this concept from AI research called the bidder lesson. The basic idea is that over and over again, we've seen that general approaches that just use massive amounts of data and computing power almost always went out against systems that are carefully handcrafted by humans. That move to an end-to-end network we talked about, that's Tesla, betting their entire company on this lesson being true for driving. So here's the bottom line. If this race ended today, Waymo wins. Their safety-first approach has proven to work in their little geo-fenced sandboxes. But this thing is a marathon, not a sprint. Tesla's approach is way cheaper, way more scalable, and could leapfrog everyone else if, and that's a big if, they can prove their AI is safe enough for every street in the world, not just the ones that are pre-mapped. And that leaves us with the ultimate question, doesn't it? We know humans can drive pretty well with just vision and intelligence, but is trying to replicate that system in a computer with all its amazing strengths, but also all of its potential flaws, is that really the right path to a fully autonomous future?